This is lecture 4G3 for Calculus 1 on minimizing business costs. In this problem, we will use calculus, use the first and second derivatives to determine the size of the order for reordering stock for your store. This analysis has nothing to do with the cost of whatever you're ordering. It has to do with the fact that it costs money. There's either a charge or costs associated with reordering, and that's right here. There's a charge to reorder. Every time you place an order, it costs you some money. Maybe the people on the other end charge you money, or it takes a person a certain amount of time and it costs you money. So this is the charge to reorder, and this is the number of times of year that you place that order. Now you could place a really big order and make it go for the whole year. You wouldn't be paying this, but you would have to store the items yourself. So you would have to pay for that. So here's another charge. A cost to store the items times the number of items in storage. This would be like an annual cost because we're talking about per year here. So we have two costs going on. One is a cost to reorder, the other is cost to store. And we want to find the number of times per year and the size of orders to place so that those costs will be minimum. Unlike most of the examples that I've worked out in this class, we're going to put numbers to this one instead of just doing it with variables. So I'm going to say, you'd have to do something to eliminate some of the variables here, and I'm going to do it with numbers. It will demonstrate the method anyway. Let's say it costs you $4 a year to store a case. And every time you place an order, it costs you $100. All right, so that cost goes right here, $4. And here's your $100 charge. Okay, say you need 800 cases over the year. You're going to use 800 cases over the year. So how many times are you going to place the order? If you order 800 all at once, you'd only have to order once a year. If you order 400, you'd have to order twice a year. So this is how you decide. X is the number of cases you're going to order, and 800 over X gives you the number of times per year you have to order, and that goes right here. So this is cost to reorder times the number of times you do it. Right. For the other, for storage, you say whatever I order, I'm going to keep half in storage. So I got to pay that $4 charge to keep those in storage right there. Okay, just do some algebra, and here is the cost. And what I want to do is use the first and second derivatives to minimize the cost, to minimize the value of this function. So the first thing we'll do is take the first derivative. I wrote the function again here so you can see. So to take the derivative, I first have to take the derivative of 2x, and I get a 2. Then I take the derivative of 80,000 over x, and I get minus 80,000 over x squared. I want to find out where this is 0, so I really want things multiplied together, so I just do a little bit of work here. I end up with a 2 over x squared and another factor of x squared minus 40,000. I will have a critical point when the first derivative does not exist. So the first derivative does not exist. If x equals 0, that means I order 0 cases. You'd have to place quite a few orders to get 800 out of that. So forget that point. It isn't important to our application. Right. So now I'm looking at this term. And when this term is 0, the first derivative is 0, and I would be at a critical point. So this term is 0 when x squared equals 40,000. Of course, there's two roots to it. One is minus 200, which again we can throw out because you can't order negative cases. So I'm left with ordering 200 cases a year. At this point, I know this is a critical point, but I don't know if it's a maximum or minimum. Potentially, it is the order that would cause me to have the most costs. So I have to investigate further by taking the second derivative. So I have to take the second derivative. I wrote the first derivative here so you can see it, or the function. Here's the first derivative, and now we've got to take the second derivative. Okay, second derivative. To do this, I have to use the product rule. I have to hold one of these terms constant, so here I'm holding the x squared minus 40,000 constant, taking the derivative of 2 over x squared, which gives me, I'd have a minus 2 times the 2 give me the minus 4, and then the x to the minus 2 would turn into x to the minus 3. I'll make that a little bigger? Maybe not. Okay. Now I go and hold the term in green constant. Let me get all that off of there. Okay, so now I'm going to hold this constant, which is 2 over x squared, and take the derivative of this term. So the derivative of x squared is 2x, the derivative of minus 40,000 is 0. So all I have is a 2x right here, having taken the derivative. Now I can put it all together. So the second derivative equals minus 4 over x cubed times x squared minus 40,000 plus 4 over x. And I want to know the sign of the second derivative. If the second derivative is positive, then this is a local minimum. If the second derivative is negative, this critical point would be a local maximum. The critical point is x equal 200. So when you put x equal 200 into this equation, well, x equal 200 is the same as x squared equals 40,000, and this first term is gone. I'll just x it off. All right, that's gone. And all I'm left with is 4 over x, x being 200. So the second derivative is 4 over 200, which is positive. This says that the critical point, x equal 200, is a local minimum. So now we have a solution. For minimum cost, reordering, and storage cost, the manager should order 200 cases 4 times a year. There's another way to find out if that first derivative is a maximum or a minimum, and that is to look at how the first derivative behaves in the neighborhood of the critical point. In this case, the first derivative is negative. If you're less than 200, it's positive if you're greater than 200. That means that the curve would be sloping down because the first derivative is negative, sloping down when it gets to 200. The slope is negative, and after that it's positive. That shows you're just tracing out a negative, or a minimum, I'm sorry. We'll look first at the graphs of the first and second derivatives because that's how we based our decision. So the first derivative is the curve in blue. There's a critical point where this first derivative crosses the x-axis, where this first derivative is negative, and that is at x equal 200. We don't know if it's the local max or local min, so we look at the second derivative. The second derivative is positive. You can barely see that on this scale, but it is positive at that critical point. Therefore, x equal 200 is a local minimum. Okay, so here's the graph of the cost for restocking and storage for your business. All right, you see sometimes this cost gets very high if you don't order very many cases and you're placing many orders per year. It also starts getting high again if you just try to make 1 or 2 big orders. But the minimum is right here, 200 cases per year. If you had a graphing calculator, you might get an idea of where that minimum is, but you wouldn't really know unless you took the first derivative. If you had this graph, you could dispense with the second derivative just based on the curvature of the graph as you see it, but you would have to take the first derivative to really find where that curve is minimum.